What is radioactivity? So the terms radioactivity is the spontaneous disintegration or breaking down of nucleus of unstable radioactive elements with the emission of alpha, beta, gamma, emission of alpha ray, beta ray, alpha particle, sorry, beta particle, and gamma what? And gamma ray. With release of what? Of energy. That's all we call what? Radioactivities. What's radioactivities once again? Is the emission of, or let me say, is the spontaneous disintegration or is the breaking down of nucleus of unstable radioactive elements with emission of what? Of alpha particle, beta particle, and gamma ray with great amount of what? Or large amount of what? Of energy. Yes, by definition. So radioactivity divine radioactivity radioactivity is the spontaneous disintegration. The word disintegration simply means what? Random, decaying, or you can say what? Breaking up. Breaking up of radioactive elements. See, radioactivity is what? Is the spontaneous disintegration. The word spontaneous disintegration means what? Random decay, or to breaking up, or to split up of radioactive what? Elements with emission. With what? Emission of alpha, particle, beta, particle, and gamma ray, resulting in release of energy. This is what? The definition for radioactivities is the spontaneous disintegration. The word spontaneous disintegration means what? A random decay. Random decay means what? To split up the what? The radioactive what? Elements. When you split up radioactive elements, when its nucleus is break, it will emit radiation, which is what? Alpha particle, beta particle, and gamma what? Gamma ray, resulting in the what? Release of what? Energy. That is what? Radio what? Radioactivities. Or you can also define it in this form, or you can also say what? Radioactivity or radioactivity is the a breaking down of breaking, let me breaking breaking up of nucleus of unstable radioactive elements. The breaking down of nucleus of unstable radioactive what elements to release or you know what nucleus of unstable radioactive elements, the nucleus of the breaking up or spontaneous disintegration. Let me, there is a mistake here, please. Let me correct it here. Is the radioactivity is the emission of radiation is the what? Spontaneous. Spontaneous is what? Disintegration of nucleus of unstable radioactive element. This spontaneous ignition method to break nucleus of what radioactive what elements to emit to what to emit radiation. So what are the radiation that is what is emit air? We call it alpha, beta, and what? And gamma. So if you define it in this way, you are still what? On the way. The radioactivity is the spontaneous disintegration of nucleus of radioactive elements in order to what? To release alpha particle, beta, gamma, and release of what? Of energy. That is what? Radioactivities. And these radioactivities, it was discovered. It was what? Discovered by Henry Curie. Henry what? Was discovered by Henry Curie. Sorry, it was discovered by Henry Becquerel. That what? Becquerel in 1896. In 1896. So the person that discovered radioactivity is what? Is Henry Becquerel in what? 1896, which was later named, but it was later named by Curie family. So the person that is what discovered radioactivity in 1896 is what is Henry Becquerel, but it was later named by what Marie Curie and her husband. Call it what Curie what Curie family. So that is what about the definition for radio what radioactivities. Before we move to the next one, we observe that what when the radioactive element is being disintegrated or breaking down, it emits what we call what radiation. It emits what we call what radiation. I put it here. It emits radiation. What are the radiation? Alpha, beta particle. So this will now lead us to the what we call what radioactive radiation. Radioactive what? radioactive radiation. So, what is radioactive radiation? It's a type of ionizing radiation that emits by nucleus of unstable radioactive elements. Yeah, radioactive what radiation? This is a what? A type of ionizing radiation that emitted that is emitted by unstable atomic nucleus by unstable atomic nucleus, or let me put what atomic nuclei. So it is a natural phenomenon that occur when atoms nucleus decaying. Atoms what? Nucleus decay or undergo nuclear reaction, or under what? Undergoes nuclear reaction. What are the radioactive radiation? They are the type of ionizing radiation that's emitted by unstable atomic nuclei. So whenever the radioactive element is undergo what radioactivities, this radiation will be emitted, or it is what phenomenon is a natural phenomenon that is occur when the atom nucleus decay or undergo nuclear reaction. The radioactive radiation will be what? Radioactive radiation will be emitted. So the radioactive radiation is the product of radioactivity. Whenever the radioactive element undergo spontaneous disintegration, it will emit radioactive radiation. So this radioactive radiation emitted from the nucleus of unstable isotope, and is a natural phenomenon. And what are the types of radiation we have? Types of what? Of radiation. The radiation is also called what? Radioactive what? Radioactive radiation. There are three basic types of radiation we have. The first one is what we have, what we call alpha. This is symbol radiation. The second one we have what we call what? Beta radiation. The third one we have what we call what? Gamma radio what? Radiation. So these are the three types of what? Radioactive radiation we have. Let me put the symbol for gamma too. So this is what? The gamma what? Radiation. So this three type of radiation, there is a scientist, is a physicist, scientist, is the one that will give us what? More details about what? About the types of what? Of radiation we have. And the name of the scientist is called Rutherford. So the Rutherford in 1904, in what? 19 what? 04. The Rutherford performed one experiment by subjecting a uranium source into the what? Into the electromagnetic bar. Let me perform the what? The Rutherford experiment is subjected what? Uranium what? Uranium salts. Assume this is the what? Uranium salts. We have it here. This is uranium salt with its own what? Nucleus. Uranium salt with its what? This is what? What? Uranium salt. This uranium is a radioactive what? Radioactive element. So all radioactive elements, they are the one that is what? Undergo radioactivity. And they will what? Emit radioactive radiation with energy. Good. So we have uranium. This is uranium what? Uranium salt. The Rutherford now what? Subject this uranium salt into the what? Into the magnetic what? Magnetic bar. And so this is a magnetic bar that is what? Subject these two. Mhm. Yes, this is what? The magnetic what? Bar. In this magnetic bar, have a this side is positive charge of magnets, and this side is what? Negative charge of what? Of magnets. Mhm. So if this is what? A radioactive what? Element, uranium. So this uranium can undergo natural radioactivities. So the emission of radiation can come out from this uranium naturally. So when this what? The radioactive radiation are coming out from what? From uranium. Observe that one of these radioactive particles is moving like this toward the what? Positive. And another one coming out from here and go to the what? Near what? Negative. And the another one is what? Is coming out and what? Move what? Up. Like this. Like I said, the Rutherford is the person, is a scientist that discovered the what? Lord Rutherford. But in 1904, is the scientist that discovered the what? The kind, the nature of what? Of alpha, beta, and gamma radiation by subjected what? The uranium salts into the what? Magnetic what? Magnetic bar. So when the radiation are coming out from the what? From the uranium salts, the one is what? Is moved up. The remaining two are deflected by what? By magnetic what? Magnetic bar. And if you could still remember from law of what? Of electrostatics in physics, we're saying that what? Like charges repel, unlike charges what? Attract. Remember the rules? Like what? Like charge. What? Repel. But unlike what? Unlike charge are what? Attract. The like charges repel, unlike charges what? Attract. For this particle now, radiation, to move toward the what? Negative to positive magnetic bar. To hold what? Positive magnetic bar, definitely. If this ray automatically moves to the what? Radiation moves to the positive, and this one moves to the negative. Abi, from this law of electrostatic charge, so that what? Like charges will repel, unlike charges will attract. Definitely, this radiation attracts positive charge. But what kind of what of charge will always attract positive charge? The charge will be what? It will be negative. So this one will be what? Negative. Because negative always attracts positive. And this one, it will be what? Positive. Going like this. And the one that is what? Does not deflected by magnetic bar is called is neutral. Is what? Is neutral. And according to the what? The Lord Rutherford, we performed this experiment to now tell us that what? The radioactive radiation that is deflected toward the positive bar is called beta. We call it what? Beta what? Radiation. The one that is deflected toward the what? Negative bar, we call it what? Alpha radiation. The one which is as what? No charge and is was not deflected by what? By magnetic bar. Instead, we call it what? Gamma ray. That is from the result of Lord Rutherford experiment. We observe that what? Alpha particle are positive what? Charge. Beta particle are negatively what? Charge. And a gamma ray is a what? Is a neutral. No what? No charge. So that is what Lord Rutherford what? Experiment. Rutherford is the one that tell us the what? The kind, the nature of what? Of radioactive what? Radiation. So the next thing that we are going to do now is what? Let us take what? All this radioactive radiation or particles were alpha, beta, gamma, one after the what? The other.